Right, the next sequence of videos will look at how we use some key pieces of mathematical equipment, namely a ruler, protractor or angle measurer and compass. We're going to be looking at using them when we're dealing with bearings, constructions and loci. In this first clip we'll be looking at bearings. So, some facts to kick us off. Bearings are used along with distance to describe how to find something, the location of an object from a given point. The convention is that we always measure bearings from north and in a clockwise direction. So the turn that we rotate from pointing north until whatever we're looking for is in our line of sight is the angle that the bearing is given for. You also need to be clear with the language that if we're saying it's a bearing of A from B means that you are actually standing at A and measuring the turn you make from pointing north to pointing at A. So the bearing of A from B means I'm here at B. I'm looking north and then I'm turning until I'm looking at A, and that turn is my bearing. If the measured angle is less than 100 degrees, a 0 is placed in front to make a 3-digit number. They're called 3-figure bearings. So a measured angle of 65 degrees would be a bearing of 065. And because when we're measuring north-south, anywhere on the globe, the north-south is always the same direction, so it creates parallel lines. So because the north-south direction is always the same, the properties of parallel lines can be used to work out angles. So in some questions you'll be measuring, other questions they'll tell you it's not drawn to scale and they're relying on parallel lines. So for example, if the bearing of A from B is 65 degrees, we can work out the bearing of B from A without measuring. So we've got here the north-south straight lines which are parallel. The bearing of A from B is 65. So that angle there is 65. Now the bearing of B from A means that we're standing at A, and what we want is that angle. Now because of the parallel lines, I've got the Z angle there. If you're not sure, quite often you're more familiar with parallel lines running horizontally rather than vertically. So you can see if that's 65, that's 65 in there, from there to there. So the bearing is from north to south, which is 180, plus 65. So 245 degrees is the back bearing, the bearing if you're standing there and looking the other way. So sometimes measuring, sometimes parallel line properties. Let's have a look at some questions. So the map shows a part of Wales. The position of Newtown is shown on the map. Write down the bearing of Welshpool from Newtown. So first of all you've got to find Welshpool, which is there. So if we then run a line through Newtown and Welshpool, the bearing will be the angle from north till we hit that line. So you take your measurer, the centre of the measurer is at Newtown because that's where we're measuring from. You line the 0 up with north. You then have to work out which scale, inside or outside. We're measuring from 0 upwards 10, 20, 30, so it's the outer scale, and on my diagram there we're looking at about 35 degrees. So the bearing will be 035. degrees. Name the place on the map that's on a bearing of 235 degrees from Newtown. So we're putting the measurer back on Newtown and we're looking for 235 degrees. So I'm at 180, 220, 235. Put a little dot, draw it through, and you can see Llangurig is where we're looking at. On a bearing of 235 degrees. So that's a question where it's all to do with measuring on the chart. Question 4. So this is a maths bearings on a maths question paper. How would the direction due west be written as a 3-figure bearing? So you need to know north, south, east, west. So due west, you have to go that way. So it's 3/4 of a turn, which is 180 plus 90, which is 270 degrees. There are 360 degrees in a full turn. A pointer facing due south is spun clockwise through 3 3/4 full turns. In which direction will the pointer now face? Well, 3 full turns, 1 full turn, 2 full turns, 100 full turns takes you back to the start. So we can ignore the 3 part of it, and if you're facing due south, so if I draw another little thing here, 3/4 of a turn in a clockwise direction, 1/4, 2/4, 3/4 means you're here and you're going to be looking east. What is the bearing of point P from point A? So you're at A and you have to turn all that way around. So you're going 180 degrees north-south plus 40, 220 degrees. The picture shows a map of Italy where 1 centimetre represents 50 kilometres. Measure and find the straight line distance from Milan to Rome. So Milan to Rome is 6 centimetres. So 6 centimetres on the page would be 50 times bigger. So we've got 5 6s are 30, add a 0, 300 kilometres. A plane flies from Milan on a bearing of 110 degrees. Radar at Rome detects the plane on a bearing of 042 degrees. Plot the position of the plane. So from Milan, 110 degrees. Centre of the measurer on the point of Milan and the 0 lining up with the north. You're measuring 110 degrees on the outside scale. And draw a line. The plane is on that line somewhere, but we don't know where. In order to know where, I have to draw a second bearing, this time 42 degrees from Rome. So I move my measurer to Rome, line the 0 up with north, and measure 42 degrees. Draw that line, and where the 2 lines cross is where the plane is. And this question now, the key thing here is it's not drawn to scale, so I can't use that to answer these questions. So a section of cable is run from Pontclew to Maes Owen and then on to Wild Edge, and we can see there the north lines drawn on. The above diagram shows a section of cable from Pontclew to Wild Edge. Write down the bearing of Maes Owen from Wild Edge. So it's from Wild Edge, so I'm standing there and I need that angle, and what I've got are parallel lines. So I've got the Z angle, but if that's 74, that bit's 74, so the bearing is going to be 180 from north to south plus 74, which is 150, no it's not, it's 254 degrees. Maes Owen from Pontclew. So now I'm here and I need that angle. Here's my north-south, there's my Z. If that's 52, that's 52. So this time I'm not going to be adding 180 on, I want to find out the difference between 180 and 52. So I'll be doing 180 less 52, which is 128 degrees. So that's bearings.